In the name of Allah, the most beneficent and the most merciful. Assalamu alaikum wa rahmatullahi wa barakatuh. How are you, dear students? Dear students, I welcome you in Pakistan International School Types virtual learning classes for the session 2020 and 21. This is class of your favorite subject, science, and you know that is for grade 6. And we are studying chapter number 11. In that, we are discussing investigating sound. Investigating sound, you have seen this topic before in the previous classes also. And in the previous lecture, we have studied that how sound is produced. Today we will see how does sound travel. So let's get started. So your chapter number 11, investigating sound. How does sound travel? Definitely that is a valid question. That how does the sound produce, that we have studied that when the molecules vibrate. So when the molecules move and strike with other molecules and they move back and forth or up and down, so they pass the vibrations of the sound to the other molecules, and like this the energies of molecules from the source of the sound, it moves towards the other or the listener. So here you can see the movement of the molecule. For example, this is a speaker and the voice is or sound is produced from the source, and from here the molecules are vibrating which are present in the air, and here the sound is produced like this when the molecules vibrate. Molecules of air, solid or liquid, they vibrate. And how do they travel? They travel from the source of the sound by passing the vibration from the molecules to molecules. They strike with the molecules and they pass energy to other molecules, then they strike to others, then they strike to other, and then they strike with other molecules and they pass the energy from the source up to the listener. So likewise, this, you can see here the sound is producing and it is spreading all around because molecules are present all around in the atmosphere, in the matter. So all around the sound vibrations are spreading. So as we go farther, so we the sound is having less energy, and in the last the sound um, is very less, or like we can say it is totally vanished. So when someone calls us from a distance, we hear the sound. It means sound travels. So, but the sound needs a medium to travel all the time. We know that in the vacuum, where is the vacuum in the atmosphere? There is no vacuum. Vacuum means when there is no particles, so there is no medium. So that is the space where there is no medium, no air, no liquid, or no solid over there. So that sound needs some medium to travel. So it means sound is a form of energy. We have talked that about before in the previous slide. So it spreads from its source in all directions, and possibly when vibrating particles hit each other and pass on the vibrations as the sound. So you can see this is the source, and where there are too many molecules, it means here is um, the upward movement of the molecules and then there's some molecules pass their energy towards the next. It means they're pressing those molecules, then some molecules take the energy and escape from there, and they pass the energy to other molecules, then to other molecules, and then to other molecules. So it makes the wave like form. This is called crust and trough, crust and trough, crust and trough. So this is the wave like movement when the molecules move from the source, and at last the molecules which is taking the sound, so they reach to our ear and we can hear the sound. And sound energy needs a medium for its propagation. Propagation means the movement, the spread of the sound. The sound energy cannot travel in vacuum due to the absence of any particles. So in the space, we cannot hear the other astronaut, and we use that for some sort of like um, walkie-talkie or microphones, etc. So, but we cannot hear the sound in the vacuum due to the absence of the particles of any type of the medium, like solid, liquid, or gas. But if there are no particles, it means there is vacuum. So the sound will not be travel. How can sound travel if there are no particles? So there is no crest and trough and no striking and passing of the energy to other molecules. Sound also loses energy as it travels from one place to the other. So when the sound moves from the source, if we are very near to that thing, whether that is an animal or a person, so there are too many vibrations over there, and that's why the sound is too high and louder. But when we are farther from the source of the sound, so what happened? The sound is lighter, or that is diminished. Diminished means very less sound. It is having less effect over there. So sound is light when we go farther. Okay, so tell me, have you ever observed that a loud sound dies after traveling for some distance? Yes, definitely. For example, we are moving from a road and there is a car passing by our car. So what happened if it makes the sound like a horn? It makes the horn. So if it is closer to us, so there is too loud sound. If it is farther away, it moves very rapidly and quickly, and it goes farther away. So what happened? The sound dies when it goes farther and farther. It means the molecules cannot take, or they lose the energy at very long distance. So when your friend goes away from you sometime, so your call does not reach them. Yes, definitely. Why? Because sound also loses energy as it travels from one place to another. So when it loses energy, so there will be no sound. We cannot hear the sound, definitely. Okay, so here is an activity that is sound transmitted through wood, plastic, metal, or cardboard. So as we know that sound travels faster um, in some materials and slower in some materials. What are these? We will talk about in the next slides. So here we are having activity that can you hear a scratch through wood that you cannot hear through air. Use a tuning fork with different material. Okay, first of all, we will see that all are solid things here. This is wood and the nail by which we will do scratching. Then we are having metal spoon and a tuning fork, plastic spoon and a tuning fork, and a book and a tuning fork. All are solid materials. So in solid materials, sound travels better and louder. But solid materials are of different types. If they are metal and they are stiff and harder, so the sound travels faster as compared to the soft and um, delicate materials. For example, as compared to the book and the metal spoon, so metal spoon will make more sound. So here we are using, first of all, the nail scratching over the wood, and we just keep it in the front of our ear. So definitely we feel more sound, we hear more sound due to the scratching. Then we will use tuning fork. Tuning fork is such type of material. You can see here it's made of aluminium. Uh, and when we use this on the rubber pad, there is a rubber pad, and we strike it on the rubber pad from here, this free end, and we hold it from this, the handle, and then it produces the vibrations like this by moving up and back and forth, back and forth. This produces the sound. And when we keep this one on different materials, so definitely these vibrations pass from these particles to the other particles, and then they make louder sound on the metal, less sound on the plastic, and far less, the least on the book. So here is an example of the vibrations produced by tuning fork. These are two free ends of the tuning fork. After just striking these free ends with any rubber pad or any material, then they make the vibrations, and we can feel these vibrations, wave-like vibrations in the water. So it means they produce vibrations, and by these vibrations, we know that when the particles vibrate and move, the sound is produced. Here, this activity can be proved by this one. So here is tuning fork on this one, and on this slab there is another tuning fork, and a plastic ball, ping pong ball, is hanging here. So what the scientist is doing, this is the rubber pad by which he is striking the free end with this rubber pad, and they are these two tuning forks are having distances, but with the vibration of the first one, the other tuning fork gets vibrated, and with this the ball is getting vibration. You can see here, it means the vibrations passes from the molecules to other molecules and particles, and hence the sound is produced. So this is very good example of the traveling of sound from the source of the sound to the other, like listener or other place, from one place to another place. So this is very easy activity. You can do this at home or for you, uh, like for your interest. Okay, the other activity is what you can hear better through your bones. Why? Because bones are the solid materials. So when you can hear, how it can be proved. So first of all, just plug your ears with fingers. Keep your fingers in both of your ears, and then produce a humming sound, like this. So the sound of a hum hears better when you plug your ears. Why? Because your sound is vibrating in your body, in your bones. That's why your bone, because your bones are solid, through which the sound travels faster. That's why you can hear your sound more clearly and louder, as if you remove your fingers and then do humming sound. Close your mouth and then produce any type of sounds, and you can hear more better when you plug your ears. So it it is proved that your that sound travels faster in the bones. Now we will see the speed of sound in different materials. So for that, sound travels by passing on its vibrations to the particles of some medium. The speed of sound depends on what kind of matter it is traveling. So first of all, we'll see air. Okay, so here in this diagram or chart, we can see the particles of gases are farther apart than in liquids and solids. Here you can see there is no motion, no vibration because there are no particles, and that is the vacuum. And if we see the gas, so gas particles are having great distance among them as compared to the liquid and solid. So it takes longer time for one gas particle to hit another particle and to hit another particle and to hit another particle. It takes longer time. So it means it lose more energy, as well as it needs to travel its energy to other particles. But if it has to take more distance to pass to another particle, to move to another particle, so definitely it will lose more energy. So in the gases, the sounds die very quickly, um, because they have to pass the energy. Energy is lost by traveling though that distance. If we see the particles in liquids, so particles in liquids are closer together as compared to gas. So sound travels more quickly in the liquids, especially in the water, than it does in the air. So that's why the animals which produces sounds in the water, so that's sound is louder as compared to which is produced in the air. So then we'll talk about the particles in the gas. They're very, very close with one another. So we have seen some activities before that in the sounds, the in the solids, the particles are very close to one another. So it is very easy to travel and strike and hit with other particles and pass their energy to other particles. So the sound travels very quickly. For example, and the metals and wood. So here we can see an example of the passing or hitting the particles in three types of medium: solid, liquid, and gas. So if you can see in the gas, it travels longer time, it needs much time, and to strike with one another it takes the time. But in solids, the molecules are very close to one another and passes the energy, and there are more energy among the particles, and you can see the particles can move very far away. But in the gases, you can see it takes more time, and there is less energy. That's why we don't go for very far. So here we can see the charts, like some materials which are solid, but how the sound travels. So the speed of sound in rubber, that is also solid, 60 meters per second. As I have told you, that if they are soft, it means the particles are having some more distance as compared to the aluminium or copper or glass, which the materials are very close to one another. Especially in aluminium, it is at 6,320 meters per second, but in rubber, it is this one. Air at 40 degrees centigrade and air at 20 degrees centigrade, these are like gaseous medium, so they are having this type of we can say the speed of the sound. So here we can see the speed of sound in gas, liquid, and solid, which is in your book, the exact one. The gas or air, it is having almost 350, we have seen here. And in liquid water, that is 1005 liquid. The medium is liquid, but the substance is water. So 1500. And in solids, especially steel and aluminium, that is 6000 meters per second. We have to remember these numbers especially. Very good activity is there, the speed of sound in different material, how you can distinguish. Like you can see, this is the first microphone or first telephone, which now we use to uh, uh, we use it for the for playing. We know that sounds travels by the particles, and particles of solids are very close to one another. So we can make the tin can telephone with two tins, and we can attach them with the thread. So this is the thread through which the sound vibrations or sound waves can travel to the other side, and we can hear the sound. So this is the basic technology for making the telephones. There is another activity. How can you see that at the speed of sound in different mediums? Now we can see this in the water. So when we are gonna hit two spoons in the water, and you just listen it very carefully by touching your ear with the this tub. So how can you see that which transmits sound more efficiently, air or water? Definitely, water molecules are closer to one another as compared to air. So in water, the sound which is produced, that is higher as or louder as compared to air. There is another activity which is related to the same, checking the speed and loudness of the sound. So you will need for that a sea level bag, um, like two ways of that. One, first of all, you fill this and blow it with the air, and then you just attach it with very close to your ear, and one ear has to be plugged in, uh, or just close with your plug with your finger. And then we must need a pencil with a rubber. So we strike this one with this um, that plastic bag which is filled with air. So what you feel, uh, then you must note down the reading. Then the same plastic bag or another one, the same type, but you fill with water, and the same activity you will repeat. So what you will feel, whether the sound travels in the empty bag faster, in which you blown in the air, or the other one which is having water inside it. Definitely water, because water's molecules are closer than the air with one another, and they can pass the energy and sound towards your ear. So we have seen here the speed of sound, as well as one more thing you can you have seen in your daily life, like nowadays that is also the rainy season. So you can see that when you see the flash of light in the lightning in thunderstorm, so you might have noticed that the sound reaches to you after some time, and you see the light before the sound. Yes, it is, because the light travels faster than the sound, and light travels in straight line, and sound travels in waves, the vibrations. So sound that light takes 8 minutes and 20 seconds. There is 8 minutes and 20 seconds uh, to reach from the sun towards the earth. And this is not actually So the flash of light, actually we see from the clouds by striking of the clouds. So they produce by rubbing of those electrons, or passing that electrons, the light energy, that electricity, that is actually static electricity, which you have read about, static electricity in grade 5. So that is produced, so that is called a flash of light in the lightning. So it reaches to the earth uh, very quickly and faster than the sound. So the sound comes after that, because sound takes too much time, because it travels in the waves also, and in the air the particles have to strike with one another to pass the sound to our ear. Some whales make sound that can be heard up to 160 kilometers away. You know that whales are the largest animal in the world. You can say in the world, not on the specifically land or water, in the world, that is the largest animal. So when it makes the sound, so we can hear the sound up to 160 kilometers, because they, when they produce the sound for signaling one another, they are producing in the water. So in the water, the sound travels faster as compared to air. One more very interesting fact is, do you know that a rabbit has long ears, and these long ears you can see here are used just to escape from the place for their safety, because they catch more sound vibrations, more sound waves, which like are produced by some animals, and then they run away from the place in for their safety purpose. So they catch more sound, so like a cat and dog, and they can also move their ears from where the sound waves are coming, so they can rotate their ears to towards that side. Okay, dear students, I hope you found this lecture very, very interesting, and like very informative as well. Now you have to judge and observe your daily life, how the sound is produced and how it is traveled. Inshallah, we will see you in the next lecture. Wish you all the best. Allah Hafiz.